as that. I have no idea why. Okay, any questions on this one? All right. Okay, so let's say, for example, I'm going to factor by grouping. Three xy plus 2 minus 3x minus 2y. Okay, first thing we want to do, make our subgroups. So that means 3xy plus 2 minus 3x minus 2y. And we make our subgroup. Now here, if you find the greatest common factor of both of them, 3xy and 2 doesn't have anything in common, so you just factor out a 1. So that leaves us as 3xy plus 2. These two have a negative 1 in common. So you can factor out a negative 1, which leaves that as 3x plus 2y. Okay. The only problem is the binomials don't match. The binomials do not match. And we can't factor them out if they don't match. Okay. So now we're just going to rearrange it a bit. Okay. So instead of 3xy plus 2 minus 3x minus 2y, remember the first step is you want to have terms next to each other that you can factor something out of. So we have 3xy and 3x. We could factor a 3x out of that one. So we can make that 3xy, and as long as you move the sign and everything, you're good. So that just becomes minus 3x. Okay, so we can have minus 2y plus 2. And then we start over again. So restart your steps. Okay, so that becomes step 1. Remember, you're going to make your subgroups. Which are those two. Okay, remember your second step. You're going to factor both. I don't know why I put greatest common factor up top when that should be factor both. Even though the greatest common factor is used. So if we factor both, this one would become, if we factor a 3x out of both of those, we factor out the 3 and the x, the only thing left is the y. And if we factor out the 3x here, the only thing left is a 1. Okay, we do the same thing here. So this, connect that one to that one. And if we factor out a negative 2 from both of those, and the only reason I knew to factor out a negative 2 is because this is plus, and we want these to match. So we want that sign to change. So if we factor out a negative 2 here, that leaves us with y. And we factor out a negative 2 here, that leaves us with a -1. Because if we distribute that back out, we want to have that as a +2. Okay, so now we know our binomials match. Okay, so as long as we have our matching binomials, we can go ahead and factor it out. So now we can go to our third step. So we factor out the y minus 1, and you can go ahead and draw a line through it if you want to. And anything that's left will go into the other parentheses. So you have 3x minus 2. All right, so any questions on that one? Okay, all right. All right, so let's say we have factor by grouping. (5x minus 10 plus x to the third minus x squared). And I'll let you start on that one. All right. For this one, if we make our subgroups, 5x minus 10 plus x to the third minus x squared, and we make our subgroups. We factor each of them. Here, we can factor out 5. That will leave us with an x here. And 5 times 2 would give us 10. Plus, For these two, we can factor out an x squared. That would leave us with an x here and a 1 there, so they don't match. So they do not match, so we rearrange. Oops. Okay, so let's say we rearrange it and we make it x to the third plus 5x minus x squared minus 10. Okay, and again, we make our subgroups. Okay, these two, you can factor out an x. So that leaves us with x squared plus 5. For these two, you can factor out a negative 1. Leaves us with x squared plus 10. Still, they don't match. You can keep rearranging and rearranging and rearranging and rearranging, and you will never get a matching binomial with this one. So this is the case where you have a prime polynomial. You can't factor it out. Okay, so no matter how you rearrange it, the grouping will not lead to a common binomial. Okay, so this is a prime polynomial. Uh-oh. Or for some of them, they may just say type in prime if it can't be factored. All right, so any questions on that one? All right.